The on-push change detection strategy in the end tells Angular that the component for which you enabled it will only ever change because some event occurred inside of this sub-component tree. So inside of the messages component template or inside of some component that's nested in the messages component. So inside of the new message or messages list component here in this case, so that an event occurred somewhere in there, or because an input value changed in that messages component. And here I don't have any input value, so that can't happen. But if it had any inputs, then if that input value would change, change detection would run for this component and all child components. In addition, you could also manually trigger change detection, and I'll get back to that later. So it's these three sources in the end: manually triggered change detection, or because an input of the component where you set on push changed, or because an event occurred anywhere in this component or one of its child components. And that's why on push can be pretty efficient, because it limits the amount of events or things that could trigger change detection, which is why you should strongly consider using on push in your components, since it can give you that extra performance optimization. Of course, using it makes no sense, though, if you have a very simple application where it simply doesn't matter, or if you have an application that's so connected that most changes affect all components anyways. But if that's not the case, on-push can be useful. So therefore, let's use it a bit more to get a better feeling for it. Here I'm using on-push in the messages component, and that already gives us a big improvement here, because now it's way less components that are checked for changes by Angular. And that's happening because the messages component, where I enabled on-push, is a sibling to the counter component. So interacting with the counter will have no effect on that messages component or any subcomponents. Now, what happens if we go to the new message component though, where I have that form, and we enable this on push mode here, change detection strategy on push. If we do that, and I go back here and I change my counter, you'll see the same behavior as before, which hopefully makes sense because nothing should change there. We didn't remove on push on the messages component or anything like that. But what happens now if I type into this message field? Well, if I do that, you'll see that all these components are re-evaluated again on every single keystroke, because I'm using two-way binding here. And therefore, an event is triggered for every keystroke, and that triggers change detection. Now, why does this also have an effect on the counter component though? Why does that happen now that I enabled on push on this new message component? Well, because on push does not restrict events from affecting other components. Instead, all on push does is it makes sure that this component does not get evaluated unnecessarily. But if an event occurs in this component, like that keystroke event, then, of course, the parent components of this component will be notified all the way up to the app component. And that then will in the end lead to the entire component tree being checked. And the only way of changing that and potentially improving the application, therefore, is to go to the place where change detection should be avoided, not in the place where the event occurred. So in this case, if the counter should maybe not be re-evaluated when we enter text in this message box here, we have to go to that counter component, not to the new message component. So it's here in the counter component where we also should consider enabling this on-push strategy. because with that, this component and all its child components will again only be re-evaluated if an event occurs in this component or any child component, if an input changes, and here I have no inputs, or if change detection is triggered manually, which at the moment also doesn't happen. So at the moment, the counter component and its child components should only be re-evaluated if an event occurs here. So if I click these counter buttons. And therefore with this change made, if I now reload and I wait for these timers to expire, you already see that almost nothing's going on right now. And you can see that if I enter into this message box, the counter component is not part of these log messages here. Neither is this info message component, which is nested in the counter, because we enabled on push on that counter component. And we could even take this a step further, because at the moment, if I change the counter, the info messages component is also still being checked. And that is happening because the info message component is part of this counter. So it's a child component, and therefore if the counter component changes, this also changes. But this doesn't necessarily make sense. We might want to avoid this. And therefore in this info message component, we can also set the change detection property to change detection strategy on push. And with that, you'll notice that after the timer expired, if I change the counter, the info message component is no longer revisited. The app component is, because again, those events bubble up in the end. The parent component of the component that changed is notified, but the other components are not checked again. And therefore, this app now is already much more efficient than it was before. And I'm still not done. I can also go to the messages list component where I now do have an input. So the idea here again would be that it should only be checked for changes if an event occurred anywhere in this component. And here I'm not listening to any events, so that shouldn't happen. Or if the input changed, or if change detection was triggered manually, which I'm also not doing. But the input, of course, can change. And therefore here we can also enable change detection and set this to change detection strategy on push in this messages list component. And as a result, you'll see that in this application here, if I enter text here into this text box, the messages list component is not being evaluated anymore. And previously that was the case. But it is re-evaluated if I save that message. Then you see that log here, where messages list is being checked, which makes sense because its input value changed once the message is being saved. And that's how this on-push strategy works, why it's a powerful tool, and why you therefore should consider using it in your components. So the on-push strategy is a pretty powerful and important strategy that you might want to consider implementing in your components. However, I did not tell you everything about on-push because there is one additional trigger that leads this component to be re-evaluated when using on-push. This component and its child components, potentially. And that would be signal changes. Now, signals are a relatively new Angular feature. They have not been part of Angular since the start. Instead, they have been added to Angular with version 17, and therefore you might not be using them in your projects. Or you could use them, but you don't like them. And if you don't use them, everything about on-push is as I explained it in the previous lectures. But if you are using signals, then signal changes indeed also lead to on-push becoming active, so to say, or will lead to this component to be checked again, this component and its child components. That's important. And in many cases, this might not matter too much because signals often change because of events which are being watched anyways. Because, as I mentioned, events in this component or child components will trigger on-push components to be checked again. And therefore, then it doesn't matter if you're changing a signal when that event occurs in such an event handler method or a regular property. That does not matter. But one situation where it could matter is if you're using a service for sharing data across components. Because then you might be sharing across multiple on-push components, and you could end up in a situation where without signals, your code might not work as expected. And that's what I'll show you next.